Hello dear friends, welcome to BYJU'S Exam Prep and I welcome all for this GATE AIMER'S 2023 series. It's a free crash course and I'm going to start with algorithms from today, my dear friends. And topics for today are the time complexity and master theorem. You can generally expect around 2 marks from this topic. Hello Kaustubh Nageshwar, very good evening and warm welcome. Okay, you can generally expect around 2 marks from this topic in GATE examination, my dear friends. This is one of the very important topic for GATE point of view. Okay, so this is about the topic for today, the time complexity and master theorem, right? And this is about me, myself, Sridhar Dhulipala. I am having 20 plus years of teaching experience and I am associated with BYJU'S from past 1.5 years. We are working on this particular project called recorded gate content. Okay, under BYJU'S Exam Prep app, the category name, please note it, learn with video lessons. You can find the video lectures recorded by me for the following subjects like engineering mathematics for all the branches, discrete mathematics, algorithms, C programming and data structures. Okay, so this is about me, my dear friends. So let us start with today's topic, that is time complexity and master theorem. But before that, I'll just discuss about this asymptotic analysis, some basic problems on that. Then we move on to the problems on time complexity, followed by master theorem, my dear friends. Okay, this is one of the very important topic for GATE point of view. Okay, as you know, it's a crash course. So a very quick way of review of the entire algorithm course will be done by me, my dear friends. Okay, in the next 4 or 5 lectures. Comparison of functions. Comparison of functions. See, my dear friends, these notations like big O, big omega, big theta, small o, small omega. Of course, I discussed these notations in a very detailed manner earlier. Those who want the detailed story of them can revisit the previous videos, my dear friends. Because it's a crash course, I'll be interested only on understanding how to use these rules than getting into details of the rules. Okay. So here, when you say Fn is big O of Gn, Fn is asymptotically smaller than G. See, you write like F less than or equal to G. Here you should understand asymptotically. That is actually, you can say that Fn is less than or equal to some constant times Gn for large values of n. For large values of n. You could able to find at least C like that, my dear friends. So that is the basic idea for this. Now, here F is bounded above by G. G is the upper bound. So generally this big O notation is what we call it as tight, asymptotic tight upper bound, my dear friends. Then comes big omega. See, big omega says it is a lower bound. You are going to get the lower bound for the function. That is when you say Fn is big omega of Gn means Fn is asymptotically larger than G. So what we need to understand is Fn is asymptotically larger than G. But once you understand that asymptotic in your mind, you can say larger also, my dear friend. But please remember, it is not regular less than or equal to regular greater than or equal to. Please remember that. Now, when you say Fn is big theta of Gn means they are asymptotically having equal order of growth. Asymptotically, these two functions are having same order of growth, my dear friends. And what do you mean by Fn is small o of G? Fn is asymptotically strictly smaller than G, my dear friend. It is not equal, strictly smaller than G. Similarly, Fn is small omega of G means F is asymptotically larger than G, my dear friends. Okay. So when you say big O, it can be asymptotically smaller or equal, whereas small o means asymptotically smaller. That point we need to understand. And when you see these things, generally we feel like, for every two functions, definitely there will be some comparisons. Here the title also suggests that we can always compare two functions, but that is not the case, my dear friends. We may not able to compare two functions at all. Okay, generally for numbers there is something called law of trichotomy. That is either A should be less than B, yeah, A should be greater than B, yeah, A equal to B. That is called law of trichotomy. But the law of trichotomy does not agree here, my dear friends. So there is one very, very famous question which is based on this law of trichotomy. There is no trichotomy for this asymptotic notation. That is, you can have functions which cannot be compared with each other. Am I audible to all of you, first of all? My dear friends, am I audible? All of you able to hear me? My audio is clear? Okay, right. Now if you observe this, n and n power 1 plus sine n. Yes, very good. Thank you, Kaustubh. Now look here, as n approaches infinity, you know sine n oscillates. Sine n oscillates between -1 to +1. Therefore, as n approaches infinity, n power 1 plus sine n value oscillates between, see, when it is -1, it is n power 0, that is 1. And when it is +1, it is n square. So it oscillates between 1 and n square, my dear friends. It oscillates between 1 and n square. That is, n power 1 plus sine n is oscillating between n, that is 1 constant, and n square, my dear friend. Whereas this is n always. So you cannot compare these two functions. So there is no law of trichotomy always, my dear friend. So given two functions, don't feel that always you can find a relation between them. You can have functions which are not related also. Please remember. This is a very important question in GATE, my dear friends. Now there are some standard results which we should know about this, asymptotic notations. The reflexivity property. Reflexivity means a function is related to itself. So related to itself is possible with big O, big omega and big theta. See here I given one example. Fn is big theta of Fn. Similarly, Fn is big O of Fn. Fn is big omega of Fn. So the reflexivity property is satisfied for big theta, big O and big omega. But this is not satisfied for small o and small omega, my dear friends. Please remember. The next one is symmetry property. The symmetry property is just satisfied by theta notation. That is, if Fn is big theta of Gn, then Gn is big theta of Fn. That is reflexive property, my dear friend. Means A related to B, then B related to A is what we call it as symmetry property, my dear friend. So the symmetry property is satisfied by only theta notation. Then the most important property is transitive property. And this transitive property is satisfied by all the notations, my dear friends. Okay? See, for example, if you see big O. Big O is like, F is asymptotically smaller than G and G is asymptotically smaller than H. Then you can happily say that F is asymptotically smaller than H, my dear friends. So not only this, F is asymptotically larger than G, G is asymptotically larger than H, F is asymptotically larger than H. So same thing. Yeah, Mrityunjay Pradhan, most of the lectures can be accessed for free. Not all, sir. Around 20% lectures can be accessed for free. Am I clear? You can access. Maybe you all are a computer science student, you know how to access maybe more than that using different logins, my dear friends. Of course, but once you log in, obviously the people will contact you. Obviously, when you like the sessions more, obviously you'll go for getting that complete recorded lectures, my dear friends. Okay, right, that is about that. Now look at this, sir. Yeah. Hope you understand. Right, now look here. If F is asymptotically equal to G and G is asymptotically equal to H, then F is asymptotically equal to H. So all the properties are satisfied by transitive, my dear friend. That is, transitive relation is satisfied by all the notations, my dear friend. There is one very interesting notation property called transpose symmetry. That is, if Fn is big O of Gn, then Gn is big omega of Fn. So that is what you call it as transpose symmetry, my dear friend. Similarly, Fn is small o of Gn, then Gn is small omega of Fn. See, obvious, no? If F is asymptotically smaller than G, G is asymptotically larger than F. F is asymptotically smaller than G, then G is asymptotically larger than F. That is straightforward property, my dear friend. See, all these properties are very, very straightforward. You can easily apply and solve the problems, my dear friends. Then there is one more property. See, my dear friends, whenever Fn is small o, that is F is asymptotically smaller, then you can say that F is asymptotically smaller or equal to G. Similarly, when F is asymptotically larger than G, you can say that F is asymptotically larger or equal to G, but not reverse. That is, whenever this happens, you can't say this. Reverse direction, you can't say. That's why converse need not be true, my dear friends. The converse of this result need not be true, my dear friends. Hope you understand. Now there is something called order of growth notation. This is what we actually use for solving the problems. See, this order of growth growth notation is abstraction to ease our analysis. In this, what we actually do is, whenever you are having an expression, the lower order terms are ignored, because the lower order terms effect will be very, very negligible for large values of n. And similarly, constant coefficient which is associated with the higher order term also ignored, because it is a machine dependent constant. So that is also ignored, my dear friends. So whenever, suppose if you are having something like, say, Tn is, say, an square plus bn plus c. According to the first point, drop lower order terms. Lower order terms are dropped. According to the second point, the coefficient of highest order term is ignored. Therefore, we can happily write this as Tn is equal to big theta of n square. See, here we also need to understand, suppose there is some constant associated with some notation, that constant can always be ignored, because the constant is a machine dependent and it is a very, very less significant for asymptotic analysis. See, asymptotic analysis means long run behavior, nothing more than that. Hope you understand. It is just telling you about long run behavior, my dear friends, nothing more than that. So that particular idea can be used here. Suppose if you are having a big polynomial of mth degree, all the lower order terms can be ignored and ignore the coefficient dropped and ignore the coefficient of highest order term, and you can say Fn is big theta of n power m, my dear friends. See, I am writing all the important properties together in a nutshell. Please remember, you can just go through these properties. It is just like a short notes, my dear friends. Please remember that. Now one more result. This result is satisfied for big O, big theta and big omega. Whenever you are having big O notation, yeah, big theta notation or big omega notation, these results are satisfied, my dear friends. Suppose T1 is big O of Fn and T2 is also big O of Fn or some Gn, then T1 into T2 will be big O of Fn into Gn, my dear friends. See, for example, T1n is big O of n square, T2n is big O of n cube, then T1 into T2 will be big O of the product, that is n power 5, my dear friends. That is what this particular result says. Whereas the second one says, if T1 is big O of Fn, T2 is big O of Gn, and you want to find the sum T1 plus T2. For example, same example, let us take T1 is big O of n square and T2 is big O of n cube. Then their sum, because when you add up them, you get n cube plus n square. That n square lower order term is ignored. So obviously you are going to get what, sir? Big O of n cube. And what is it? It is maximum of n square and n cube, my dear friends. That's why you get big O of n cube. So that is the logic, my dear friend, nothing more than that. Hope you understand. Now, the most ordering which generally they ask in your GATE examination are based on this, my dear friend. Most of the ordering questions, they'll ask you the question, arrange them in the sorted order. What is the correct order of the following function? That entire story is based on this result, my dear friend. Those who understand this result properly, most of the questions can be answered just like that. See, generally I find people do a lot of, messing up with the questions based on the ordering of the functions. Because we do not know the rules. Without knowing basic rules which actually give the relation between the function, how can you solve the problems? So please remember that. That is very, very important. And this is the important result. Here see, the value of A is positive real number. B is any positive real number, and C is a positive real number greater than 1. If these three conditions are satisfied, then this particular ordering is possible. That is, log n power a is asymptotically smaller than n power b, is asymptotically smaller than c power n, is asymptotically smaller than n factorial, is asymptotically smaller than n power n, is asymptotically smaller than 2 power n, my dear friends. This is the relation, basic relationship between functions, my dear friend. Suppose if I ask log n whole power 1000 and n power 0.00001, which one is larger? Let us call it as f and let us call it as g. Please tell me whether f is asymptotically smaller than g, or g is asymptotically smaller than f. Please tell me whether 1 is true or 2 is true. What is the correct answer? See, I am telling you, my dear friend, these ordering questions are basic, very simple questions, but I don't know why people mess up with this. Yeah. So, G is smaller. Which one is smaller? First one or second one? Mrutyunjay Pradhan, please answer whether 1 is correct or 2 is correct. 1 or 2? Yeah, 1 is correct. See, even though it is 1000, see, for small values of n, G may be smaller than F. But for n very large, when n is very large, see, asymptotic notation does not or is not for small values of n, sir. Asymptotic behavior is what you call it as limiting behavior or large run behavior. If you don't understand, you always mess up with this, my dear friends. Please remember. Okay, so this is larger because of this property. Log n power a, any real number, is asymptotically smaller than n power b, where b is any real number. B is any real number. See, you can practice this properly, my dear friend. Now look at this. N power 10 and 1.0000001 whole power n. Which one is larger? See, 1, let us call it as f, and again g. F smaller than g. Second, g is smaller than f. Again, same story. Please answer. Which one is smaller? 1 or 2? No one knows. Still, n power 10 looks larger for many people, but asymptotically, this is larger. That is, exponential fellow always dominates any polynomial fellow. Exponential fellow dominates any polynomial fellow, my dear friends. That is, g is smaller than f. Second one is correct. Sorry, f is smaller than g. Sorry, f is smaller than g. That is, polynomial is smaller than g, my dear friend. One only correct. Please remember this. Now, this dominance ranking which people give. Okay? See, this dominance ranking which people give, sir. This is basic dominance ranking. Don't worry. Anyhow, PDF will be available. So, don't worry about it. So, I'll just come out of this. Hope you can see the entire dominance ranking. Now look here. 1 is asymptotically smaller than log n, is asymptotically smaller than root n, is smaller than n. See, between 1 and n, we can have log n, then followed by root n. Log power anything will be smaller than n power anything. That you need to understand. So, this is the basic dominance ranking. See, from this, you can get this ranking very easily. Just in place of n, you put log n. In place of n, if you put log n, it is log n, it is root log n, it is log n, and here you see log n whole square. Okay? See, all these fellows will be smaller than root n, sir. That is, This log n, root log n, log square n, log cube n, log power 100 n, any fellow will be smaller than root n, my dear friends. All these fellows will be smaller than root n. See, this basic order of growth one should always understand. If you do not know this basic order of growth, you solve 1000 problems, still you will have, you'll find some problem there. See, generally people substitute some n value 2 power 10, 2 power 100 like that, they do it. See, my dear friend, that is fine. But without knowing basic order of that, you always need to solve the problem unnecessarily. Okay? See, we can also answer these questions properly if you just know basic order of growth, my dear friends. Basic ranking, dominance ranking you call it. If you know the basic dominance ranking, majority of the questions can be solved just like that. I'll show you few questions now. And one more very important rule, please remember this. Note this rule, my dear friend, very important one. See, of course, this condition must be satisfied. But for basic problems which we solve, this condition need not be verified. Obviously, it will be satisfied. If psi n, okay, is increasing and bounded function and log phi n is less than, that is, if you are not liking this psi and phi and psi, you can just say that log fn is smaller than log gn. Then you can say that fn is smaller than gn, my dear friends. That is what this rule says. See, if it is smaller than log gn, then only fn is smaller than gn. If it is equal to, there is no rule for that. You have to find some other way to verify the order of growth or the relation between the functions, my dear friends. Only when log fn is smaller than log gn, then only you can say fn is smaller than gn. But fn is smaller than gn, you cannot do it in the reverse order, my dear friends. When this happens, then right side will happen. Please remember. And one more very important formula, because you all do mathematics also, basic limit formulas. If you want to find the relation between two functions, you can just try limit formula also, my dear friends. Limit fn by gn, you do it. If you get limit fn by gn as some a, some value a you get. Suppose if a is 0, see, when a is 0 means the denominator is larger. A is 0 means denominator is larger. That is, fn is smaller than gn. Fn is smaller than gn, my dear friends. Suppose a tends to infinity means denominator is larger, then f is larger than g, my dear friends. F is larger than g. And suppose a is a non-zero finite quantity, then f and g are having equal order of growth, my non-zero and finite value. Non-zero and finite value, then they are of equal order of growth, my dear friends. So these are the rules one should know if you want to do dominance ranking. And majority of the people, without knowing any of the rules, they want to see the relation between functions, which is impossible, my dear friends. Now I'll show you some problems. Let us see how quickly you can answer this question. You can try this problem, sir. Let me tell you the method for solving such problems. First, identify the basic relationship between the functions which you know. There will be some odd functions which are not in our list. Then take those functions and compare with the other functions and see where they can be placed. That is the procedure. Anyone? D, A, C, D, B, E. Mrutyunjay Pradhan says. Now look here. Okay, someone answered, so let me answer this question, sir. First of all, let us see our basic ordering. You should always remember this. Log n power a is asymptotically smaller than n power b is asymptotically smaller than c power n. This basic ordering we know, and this is smaller than n factorial is smaller than n power n. That is also fine. Now in this, what comes under that particular figure? Now if you see n power 1 by 3, n power 7 by 4, both are polynomials. Obviously n power 1 by 3 is smaller than n power 7 by 4. We know that. Now here this n into log power 9 will come. N into log power 9 will come. This is actually n into something. So obviously n power 1 by 3 is smaller than n into something, that is log power 9n. Now I want to check what is the relation between these two fellows? Now if you see 7 by 4, 7 by 4 is what, sir? 1. What is the remainder? 1 3 by 4, no? 1 3 by 4, which is 1 point something or 1.75. Correct or not? 1.75 it is. And so if you compare n log power 9n with n power 1 into n power 3 by 4, if you compare, these two are same. So you have to compare log power 9n with n power 3 by 4. Which one is larger? Obviously this is larger. So here this is the relation between them. Therefore this is the relation between them. That is n power log 9 is smaller than n power 3 by 4. So we got already some basic relationship. That is n power 1 by 3 is smaller than n log power 9n is smaller than n power 7 by 4. And e power n is always larger than this fellow. Now we have two fellows. One is e power n and this fellow. Now e means 2.7 something power n and it is 1.00001 power something. And any exponential fellow dominates polynomial fellow. So obviously this is smaller than 1.00, how many zeros? 3, 4, 5, 6, 7 zeros. 4, 5, 6, 7 zeros, 1 whole power n, and that is smaller than e power n. So n power 1 by 3 means a, this is d, this is c, and this is e, and this is b. So it is ADCEB, my dear friends. It is ADCEB, my dear friends. It's not ACDEB, it is ADCEB, my dear friends. So option A is the correct answer. So what is the correct answer for this? Option A is the correct answer. See, if you can find the basic relationship, the oddments need to be whatever odd function is there, that need to be find its correct position. That you can always do it. Next question. Please try this question also in a similar manner. Okay. See, my dear friends, here you know it is constant, and you know constant is smaller than root n is smaller than n, and there is a log n. You know log n is smaller than root n. So let me first clear this. 10, then log n, then root n, then n. So this ordering we know it. This basic ordering we know it. Now which fellow is the odd fellow? 100 by n is the odd fellow. So try to compare with every function in this, my dear friends. So let us start with comparing 100 by n with, compare 100 by n and 10, my dear friends. You can just use limit notation. Limit as n approaching infinity, 100 by n by 10, which is equal to 0. When limit tends to 0, the denominator function is larger. That means 100 by n is smaller than 10. So where this 100 by n should come, sir? 100 by n should come to the left of it. So that is the correct ordering, my dear friends. That is 100 by n, 10, log n, root n, and n. So that is 100 by n. Okay, this is available in option B. So B is the correct answer for this, my dear friends. What is the correct answer for this? B is the correct answer for this. Hope you understand. The next one. Next one. Now we have 2 power n, n factorial, n power log n, my dear friends. We have 2 power n factorial, and n power log n, my dear friends. Okay. See, in this particular problem, if you observe, 2 power n and n factorial. We already know that according to our basic order of growth, log n power a smaller than n power b smaller than c power n is smaller than n factorial. There is nothing more than that, my dear friends. There may be n log n which may be troubling you. Let us come to that. See, in this, according to this, definitely 2 power n is asymptotically smaller than n factorial. That relation you already know it. Now this n power log n we have to compare. See, what you can do is, you take n power log n and you take 2 power n. See, if you apply log for this, what happens to this? What happens to this log, my dear friends? Log n for this. This is log n, and it is n. So what happens, sir? If you apply log, it is n log 2 and it is log n into log n. So you got log n whole square is smaller than n. Correct or not? Therefore, you can say n power log n is asymptotically smaller than 2 power n, my dear friends. N power log n is asymptotically smaller than 2 power n. So this is the order of growth for them, my dear friends. This is the order of growth for them. N power log n. Am I clear? Hope you understand. So you just need to identify this n power log n is nothing but h smaller than f smaller than g. So you let us see this. F is big O of gn, correct? G is big O of hn. That is wrong. G is big O of fn is wrong. F is bounded below by gn is wrong. H is big O of fn, correct? G is bounded below by fn is correct. So the correct answer is option D, my dear friends. What is the correct option, my dear friends? Option D is the correct answer, my dear friends. All of you able to follow? Is the idea clear? Now let us take one more problem. Try this. The next problem. See, here we have f, which is 3 into n power root n, g, which is 2 power root n log n, h, which is n factorial. Now let me tell you one thing. Here, you know this a power log b, this a and b can be swapped. So here you can swap. Okay, first of all, for that, let me rewrite this. Then we'll swap it. Before swapping, we have to see this. This is 2 power log n power root n, because root n log n is nothing but log n power root n. So now you can swap these two fellows. So this is n power root n power log 2. Log 2 is 1. So what is the answer? This is n power root n, my dear friends. So this is n power root n. Even f is n power root n. That is, f and g are asymptotically having equal order of growth. F and g are having asymptotically equal order of growth. They are having equal order of growth. They are asymptotically same, not less than or equal to. They are asymptotically same fellows. So we just need to compare with n factorial. So now let us compare with n root n with n factorial. Let us compare these two. What you do is you apply log on both sides. Log n power root n and log n factorial. And you know log n power root n is root n log n, whereas log n factorial is theta n log n, my dear friends. So obviously which one is smaller? Obviously which one is smaller? Root n log n is smaller than n log n, my dear friend. That means log n root n is smaller than log n factorial. Therefore, n power root n is asymptotically smaller than n factorial, my dear friends. So which one is correct? So here the relation is actually f and g are equal, and this n root n is asymptotically smaller than n factorial. Okay. So here what is this? This n factorial means h. So he says h is bounded above by f is wrong. H is bounded above by g is wrong. G is not bounded above by f1. See, when they are having equal order of growth, see, whenever it is of equal order of growth, you can say f is big O of g and there is nothing wrong, or g is also big O of fn, you can say. So this not is wrong, therefore this is wrong. So what is correct? F is big O of gn. They are of equal order of growth, you can say big O, no problem, sir. If they are of equal order of growth, you can say one is big O of other one. No wrong, nothing wrong in this. So correct only. Oh, correct only, no? That is right. So it is correct only. So that is option D is correct. Now let us start with time complexity, my dear friends. See, the amount of computing that is the amount of computing time taken by an algorithm to run to completion is what is called as time complexity, my dear friends. But we don't find exact running time, because it depends on many things, like processor which you are using, many machine dependent issues it will depend on. So we try to approximate it. So how you approximate? So the computing time, we try to approximate it as number of statements executed. Okay, so here it is cost of the statement into number of statements executed, because for each statement there will be some constant, some cost will be there. That cost we assume it as some constant. So cost into number of statements over all the statements, we try to take it as time complexity. My dear friend, it is just an estimation for time complexity, my dear friends. And generally this depends on this particular time complexity. Whatever you done is function of input size, my dear friends. It would be function of input size. So we estimate time complexity as function of input size, my dear friends. Now what I do is I give you some standard results. Okay. With this, most of the problems can be answered very, very quickly. Suppose whenever you are having loop from 1 to n, and every time you are incrementing by some constant, or you are going from n to 1, decrementing every time by some constant, then the time complexity is simply theta n, my dear friends. The time complexity is simply theta n. For example, suppose some code I give you for I is equal to 1, I less than or equal to n, I plus is equal to 5. Some code goes here. What is the time complexity of this particular code, sir? So as long as you are adding constant every time and trying to reach n, as long as this is constant, we just take this complexity as theta n, my dear friends. So we take that approximately this loop iterates how many times? N times. Of course, the coefficients are ignored here. The coefficients, constant coefficients are ignored, my dear friends. So we take it as n times. How many times that loop iterates there? See, that n is not exact value, approximate time. So that is the first rule, my dear friends. Not only that, look at this example. Suppose you are going from, say, suppose x is some 0. Of course, that not needed, some code. What I mean to say is some code. Here there is some code. Some code goes here. For I is equal to 1 or n, I greater than or equal to 1, I minus is equal to 2, and some code goes here. See, as long as this constant increment is done and you are reaching from 1 to n, the loop iterates n times, my dear friends, ignoring the coefficients. So what is the time complexity for all such problems? The time complexity would be theta n, my dear friends. The time complexity would be theta n for such problems. The next type of important loop is the following. For I is equal to 1, I less than or equal to n, and what is that you are doing? Every time you are multiplying the I value, that is incrementing is by a constant multiple. Every time a constant multiple is multiplied and the I value is incremented. In such case, or starting from n to 1, every time you are dividing by a constant value, same constant value. In this particular case, the time complexity would be what, sir? The time complexity would be theta log n, my dear friends. What is the time complexity? Theta log n. That means the loop iterates approximately log n times, my dear friends. The loop iterates approximately log n times, my dear friends. Hope you understand. Now, for example, if you are having some code like this, some code goes here. What are code? For I is equal to 1, I less than or equal to n, I into is equal to 5. Some code goes here. So what is the time complexity for this particular code, my dear friend? This type of questions they'll ask you. Of course, later on they combine these rules with other rules. The nested loops you are going to get. Once you understand this logic, that logic can be easily extended, my dear friend. So what is the time complexity? How many times the loop iterates? The loop iterates log n times. So the complexity is theta log n, my dear friends. The complexity would be theta log n, my dear friends. The next type of important rule here is, see, we start with not 1, here some 2 or some constant. Every time you are raising the value of the current value of I by a constant value. Raising the value of I by a constant value. You are reaching n. In this particular case, or you are starting from n, you are reaching up to some constant 2, and every time you are taking the 1 by cth root or cth root of that particular I and reaching 1. In both the cases, the time complexity would be what, sir? What is the time complexity? Theta log n. That means this loop iterates log n times, my dear friend. This loop iterates log n times. Okay? Please remember that, my dear friends. Okay? See, here it is actually, you start with 2. Every time it is 2 power c. 2 power c square, 2 power c cube, like that you have to continue up to 2 power c power k minus 1, which is equal to n. So that means what, sir? C power k minus 1 is log n, and k minus 1 is log n to the base c. Approximately base of logarithm does not matter. You can happily write it as log n, my dear friends. So that is how we get this particular formula. Okay? Please remember the standard rules, my dear friends. If you do not know the standard rules, again you will be having lot of trouble. Please remember this standard rule 1, standard rule 2 and standard rule 3. Very important for gate point of view. Please answer this question, my dear friends. What is the time complexity of this code? Theta of n. See, my dear friend, here the value of x is 10. And what is the value of n here? What is the value of n here? N is x. So n value change it to 10. So actually this loop iterating from I is equal to 1 to I less than or equal to 2 power 10. That is 1024 I plus plus. Hope you understand. That means as long as it is a constant, it is constant only. So how many times how many times the loop is iterating, my dear friends? The loop is iterating 1 to 2 power 10. That is 1024 times approximately. Therefore, the time complexity of this is constant, my dear friends. The time complexity of this is constant, my dear friends. This is constant time complexity. The next one. What is the time complexity of this code? See, class may go up to 8:15 or somewhere, because we complete time complexity followed by master theorem results. Okay? They are very important for gate point of view. It's a quick review. Those who understand this is sufficient for gate point of view also, because any questions will be based on the same idea. See Pradhan, again story is like this. I is starting from 1. Next time the value of I is 1 plus n by 3. Next time again it is incremented by n by 3, that is I plus 2n by 3. Next time it is again incremented by n by 3, that is n plus 1. That means how many times I iterated, sir? It iterated 1, 2, 3 times. Constant times. See, continue means what, sir? It enters and continue with the next iteration, sir. Suppose if it is break, you will immediately come out of that. But if it is continue, the remaining portion of the loop is ignored and you start with the next iteration, my dear friends. Whatever it is, this, how many times it iterates? Constant times. So the answer is A, my dear friends. Answer is A for this, my dear friends. Next one. What is the answer for this? This is one of the important variation, my dear friends. See, if you observe this particular problem, the story goes like this. Here, I is equal to 1, then x value will be, starting with 0, x value will be 1. And you are adding I, what you are adding? 1 plus the current value of x, that is 1. So next time I value will be 1 plus 1 and you enter. As long as this is less than n, you are going less than or equal to n, you enter. Now x value will be updated to 2. Next, what happens to I? Already I value is 1 plus 1. To that x value, that is 2, is added. Next time x value will be 3. So you continue like this till you get 1 plus 2 plus 3 plus and so on. Something like k you are going to get. And you have to continue this process till this I value is less than or equal to n, my dear friends. Am I clear? Somewhere some k is happening, 1 plus 2 plus every time. That new value of x, that is next time 3 added, next time 4 added, like that. Some k is added. You may get that 1 plus 2 plus 3 plus and so on up to k is less than or equal to n. You have to continue. So let us see this. 1 plus sum of this. Sum of first k natural numbers, k into k plus 1 by 2 should be less than or equal to n. Approximately you can say k square should be less than or equal to n, that is k should be root n, my dear friends. So how many times the loop iterates, my dear friends? The loop iterates root n times. So what is the complexity here, Babu? The complexity here is theta root n, my dear friends. The complexity here is theta root n. The next problem. See, nested loop means, see, idea is very simple, sir. Within a loop, you are having another loop, my dear friend. Nesting of the loops is happening. So here for nested loops, we generally use this logic, my dear friends. See, there is something called independent nested loop. See, when it is independent nested loop, what happens? The value of I does not affect the value of j. So here, how many times the outer loop iterates? I varies from 1 to n. Every time you are incrementing by n means it iterates n times. How many times the inner loop iterates? It also iterates from 1 to n times. So, number of times this n into n, because for every iteration of outer loop, inner loop iterates n times. For n iterations of the outer loop, the inner loop iterates how many times? N into n, n square. So, the complexity is simply product of these two, my dear friends. So, the time complexity is simply theta n square, my dear friends. Theta n square would be the time complexity for this. Now you can do this nested loops, my dear friend. For this, you just remember the previous rule. You can combine those rules to get these answers. See how many times this will iterate, sir? It will iterate n times. So in the multiples of 2, you are reaching n. So this will iterate log n times. So what is the time complexity for this, my dear friend? Just multiply those two things. That is theta n log n, my dear friends. That would be the time complexity. Again here, the outermost loop iterates n times. Next loop, here it is in the every time you are adding 1 and you are reaching up to n squared. So this inner second loop will iterate n square times. Now this is very interesting. You are reaching up to n square but in the multiples of 2. So how many times it iterates? It iterates log n square. Log n square is what, sir? 2 log n. That means log n times. So please note that point, my dear friends. So what is the time complexity for this nested loop, Babu? Theta n into n square into log n. And that is nothing but theta n cube log n, my dear friends. So the answer for this is simply theta n cube log n. Again, now every time you are adding 1 and you are reaching n, so how many times this loop iterates, Babu? It iterates n times. Now if you see the next loop, cube root of j, the third result. How many times it iterates, Babu? Log n times. And what about this innermost fellow? With multiples of 2 you are reaching n. There are independent loops. So how many times it iterates? Log n times. So the time complexity for this would be theta n into log n into log n, Babu. So that is the result for this. Now dependent nested loops. See, for dependent nested loops, here if you observe I value varying from 1 to n and j value varying from I to n, my dear friends. See, actual method for solving this problem is like this. Sigma I varies from 1 to n, then inner loop varies from j is equal to I to n, and every time what how many statements are executed? Only one statement. So this is actually the procedure, my dear friends. See, if you want, you can expand this to get the required answer. I is equal to 1 to n. Here, if you observe this inner summation, you are reaching from what? I to n. See, whenever you are going from lower bound to upper bound, the number of elements is given by upper bound minus lower bound plus 1. So this value will be n minus I plus 1. How many such fellows will be there? N minus I plus 1 will be there. So you have to give the summation for this, my dear friends. So this is sigma n. N is constant here. So sigma n into 1 minus sigma I plus sigma 1. And sigma 1 is nothing but n. So it is n into n. Sigma I is nothing but n into n plus 1 by 2. And sigma 1 is nothing but n, my dear friends. So now what happens? This is n square minus n by 2 plus n. So you can simplify and get the answer. That is 2n square minus n square, that is n square. And this is 2n plus n, that is 3n. Hope you understand. So whatever it is, because this is the time complexity in this, we are going to ignore. You can write like half into n square plus 3 by 2n. The lower order terms are dropped. We drop lower order terms and ignore the coefficient of highest order term to get the asymptotic answer, that is Tn is equal to theta n square. See, actually speaking, this is the complete procedure when you are having dependent loops, my dear friends. But generally, we use this rule. In general, when the upper bound of the loop variable depends on some other variable, see here, if you consider this, upper bound depends on this I, this j variable value depends on I. In such cases, you can take largest value of the bound. So instead of considering this summation notation, what is the largest value of I? I largest value is n. So that can be taken as n, my dear friend. So inner loop can be taken as, instead of getting exact value, you can take it as n, my dear friends. You can take it as n. That is actually the upper bound or the value, the highest value of the bound fellow. Because j depends on I, and j depends on I, and i's largest value is what? N. So that is taken as the bound for this inner loop, my dear friends. So that is the logic which you are going to do. So instead of doing all this stuff, you can simply take this is n times, and here for inner loop we take the bound or the highest value of I. We take bound as highest value of I, which is highest value of I. Highest value of I. What is highest value of I, sir? N. That is taken as the bound for inner loop, my dear friends. So in this case, what happens? The time complexity will be simply the bound. That is big O of n square. See, generally when you take such bounds, instead of saying theta, we have to mention big O, because we don't know exact answer there. So we just taken the upper bound only. So we take big O there, my dear friends. Okay, but by this method I can say exactly theta n square, but if you use this bound method, you can only say the answer is big O of n square. Please remember that. Please remember that, my dear friends. Hope you understand. Next one. See here, instead of going summation notation, I'll go with the bound notation for this, my dear friends. So if you see the outermost loop, it iterates n times. Now the inner loop depends on the value of I. And what is the highest value of I? N. So it goes up to I square. So what is that? I take n square. I square. I highest value is n. I into I means I square is the highest value. So that depends on the value of I. Now I take the highest value of I, that is n. So I is n means I square is n square. So it taken as n square times. Again here it depends on j. What is the highest value of j? Highest value of j is n square. So this also iterates n square times, my dear friends. So the time complexity of this particular code would be big O of n power 5, my dear friends. The time complexity of this code would be big O of n power 5. Okay. And there is one very, very important code which we are having. Very often they ask this in GATE also. This particular code, whenever you find, you can remember this, my dear friends, or you can derive this particular rule. Okay, those who are interested can derive using summation notation. You can easily derive this, my dear friends. Okay, summation notation means here what happens when I is equal to 1, then j value varies from 1 to n in steps of 1. That is inner loop iterates n times. When I is equal to 2, inner loop approximately iterates n by 2 times. For I is equal to 3, inner loop iterates approximately n by 3 times. Continuing this way, when I is equal to n, inner loop iterates n by n times, that is 1 time. So how many times that nested loop iterates, sir? The total loop iterates will be your time complexity, which is n plus n by 2 plus n by 3 plus and so on, n by n. Taking n common, it is 1 plus 1 by 2 plus 1 by 3 plus and so on, 1 by n, and this is approximated with log n, my dear friends. So the time complexity of this code, whenever you find the combined code, not single code, sir, this combined code is having that particular result, please remember. This combined code is having this result, that is theta n log n. Not single. This combination is having that particular n log n complexity, that we should remember. The combination is having the complexity n log n, that we should remember. So that here also we can use this. For example, this loop iterates n times, and here j value, and this depends on j value, but this combined code is having complexity n log n, that is it iterates n log n times. So the total complexity for this would be n into n log n, that is theta of n square log n, my dear friends. Theta of n square log n is the answer for this. See, these are all the standard problems. Generally, most of the questions, 99% questions will be based on these ideas, sir. If you can just vary them here and there, the other type of questions can be framed, my dear friends. Please remember that. Now, when you talk about time complexity, we generally come across 3 terms. One is called best case, the other one is called worst case, and the last one is called average case. See, the biggest misunderstanding is people feel that best case means big omega notation, the worst case means big O notation, average case means big theta notation. There is nothing like that, sir. For every case also you can have all the 3 notation. See, for a function we can have different types of bounds, my dear friend. For a function, we can have different types of bonds. That is asymptotic upper bond, tight upper bond we call it, and asymptotic tight lower bond, and asymptotic tight bond we call it. That is asymptotic tight upper bond is big O notation, asymptotic tight lower bond is called big omega notation, asymptotic tight bond is big theta notation. That's it. Don't never do this kind of misunderstanding or wrong misconceptions like, best case means big omega, worst case means big O. That is a wrong understanding, my dear friends. Best case means what, sir? The smallest running time performed by an algorithm for any input of given size, my dear friend. Whereas worst case is, it is the largest running time performed by an algorithm. Whereas average case is not average time, sir. It is expected running time performed. Expected running. It depends on the probability distribution, sir. We know expected value of x. So that depends on the probability distribution, my dear friends. It depends on the probability distribution, my dear friends. So that is the story about this time complexity, Babu. And mostly we use this worst case complexity because of the following reasons. See, worst case is giving you guaranteed upper bound. That is one reason. And worst case often occur fair often, regularly. And average case, in many cases, even though you use probability, you learn probability, you find average cases. But in most of the cases, that average case turns out to be worst case in that particular many problems. Okay, and finding average case is difficult because you need to go to a mathematics person, or you need to learn mathematics or expectations and all to learn them. Okay, because of these reasons, mostly we use worst case, my dear friend. Because worst case means it cannot go beyond this. This is the upper bound. So upper bound is what we require. See, when you are anyhow estimating something, what you ask for, what is the maximum value? So that you can plan up to that. It cannot go beyond that. That is the idea. Then comes the master theorem, my dear friends. Okay. So the master theorem, let us start with master theorem, Babu. See, for divide and conquer recurrence relation of this particular form, Tn is equal to A into Tn by B plus Fn, where A greater than or equal to 1. It can be 1 or greater than 1. B should be greater than 1 only. It cannot be 1, sir. Okay. See, this is called divide and conquer recurrence relation, my dear friends. We have 3 cases for this. The first case is Fn is bounded above by n power log A to the base B. Not only that, even if you subtract something from this C, still n power log A to the base B is dominating Fn. Then the time complexity is given by n power log A to the base B. Suppose if both are having equal order of growth, then time complexity is either you can write Fn log n, yeah, n power log A to the base B log n, my dear friends. Now suppose if Fn dominates. Suppose the third case says Fn dominates, and if this regularity condition is satisfied. Of course, you don't have to verify this regularity conditions for polynomial problems, because if Fn is polynomial, obviously this regularity condition will be satisfied, my dear friends. Okay, that regularity condition is satisfied. That is Fn dominating and Fn is satisfying regularity condition. Then Tn is theta of Fn, my dear friends. So this is basic form of master theorem, my dear friends. This is the basic form of master theorem, my dear friends. The first problem. See, generally for master theorem, there are 2 ways of looking at it, sir. See, here this, you have this A, you can do n power log A to the base B, that one people do it. The other way of looking at it is, they take Fn is of the form some n power k, that polynomial form. Of course, there is a variant of this also available. Am I clear? Then they see this relation between A and B power k. If A is greater than B power k, which actually comes under the case 1, my dear friends. This is actually comes under case 1. So let me write it here. See, if A is greater than B power k, n power log A to the base B will dominate n power k. This n power k, it will dominate. So generally they compare this A greater than B power k. They check that. Okay, if at all Fn is of the form n power k, they just use this particular method like A B power k comparison, my dear friend. Whereas the second one comes under A is equal to B power k, and the third case comes under A less than B power k, my dear friends. When this is for Fn is of the form n power k. This is for Fn is of the form n power k, my dear friends. Of course, there is a variant of this. Fn is of the form n power k log power Pn. That also I'll give you immediately after this, my dear. First of all, let us see this. Of course, I generally prefer the basic application of master theorem, because in GATE, generally they'll ask you the basic application of master theorem, not the variant they'll go for. So here, A is 4, B is 2. Just compare n power log A to the base B with n power log A to the base B with Fn. This is compared with Fn, my dear friends. That is n power log 4 to the base 2, you compare with n. So it is n power log 4 is nothing but 2 square, which is nothing but 2 log 2. Log 2 is nothing but 1. So it is n square and n. Which one is dominating? See, whenever n power log A to the base B dominates, he is the highest, then directly you can write time complexity is theta n power log A to the base B, that is theta n square, my dear friends. So that is the time complexity, my dear friends. That is the direct complexity, my dear friends. Just it is about comparison of these two fellows. If this dominates, time complexity is this. If this dominates, provided Fn is polynomial, then Fn is the time complexity. If both are equal, then just multiply that with n, log n, my dear friend. Just multiply with log n, my dear friends. For example, you see this. Here A is 9, B is 3, Fn is n square. Compare n power log A to the base B with Fn. So that is n power log 9 to the base 3 versus n square. And you know log 9 is nothing but 3 square. So it is log 3 square to the base 3 versus n square. So this is nothing but n square. Log 3 to the base 3 is 1 versus n square. Both are of equal order of growth. Both are of equal order of growth. In this particular case, what is the time complexity? By case 2 of master theorem, theta n square log n. By case 2 of master theorem. By case 2 of master theorem, this is theta n square log n, my friends. Hope you understand. Now this is the condition. Now here A is 4, B is 4, Fn is n square. Now if you consider, okay, what is it? N power log A to the base B compared with Fn, which is, what is Fn? N square. In this case, what happens? N power log 4 to the base 4 compared with n square. This is n, because log 4 to the base 4 is 1. So n versus n square. Actually, Fn is dominating. You have to check the regularity condition, but for polynomial, regularity condition is obviously satisfied. Regularity condition is satisfied. So happily what you do? Tn is equal to, which is dominating? Fn is dominating, theta of Fn is the answer. Very good, sir. Very, very good. Super. Theta of n square in this case. Now this is what we call it as extended master theorem. See, actually the situation is exactly same as the previous result. Only thing is that Fn instead of n power k form, it will have log power p, my dear friends. Log power p form. And if you actually observe, if A is greater than B power k, it is exactly same as first rule of, it is exactly same as first case of master theorem, regular master theorem. So, if A is greater than B power k, directly Tn is n power log A to the base B. That is, here also you can just compare n power log A to the base B with, see this log power Pn, you just keep it aside. Log power Pn, you just keep it aside, sir. You compare with n power k. See, if it is dominating, directly this is the answer. Now suppose if both are equal, A is equal to B power k means n power log A and n power k both are equal, then according to this you write down the result, my friend. According to this p value. P greater than minus 1 means what, sir? P greater than minus 1 means whatever, log power, p value greater than minus 1, what you need to do? Earlier you are used to write, you are just used to multiply with log n, no? Instead of log n, if that log fellow, extra log fellow is there, no? That log n into that log power p will be there. It is exactly same as our regular second case of master theorem, my dear friend. It is just same as our second case of master theorem, my dear friend. But when p is minus 1, that is by log n if you are having. By log n if you are having. In that particular case, just that n power k or n power log a to the base b is there, no? In that you just multiply with log n. That is if it is divided by log n. And if it is something like log n in the denominator, this is the case when denominator you are having log n in such cases, just write only n power, that log n factor is completely ruled out. The log n factor is completely removed, my dear friends. Whereas this a less than b power k is same as our third case. And in this particular case, it depends on the value of p greater than or equal to 0 or p less than 0, my dear friends. See, my dear friend, if it is p greater than or equal to 0, in that case, it is same as our regular case. This is our case 3 of master theorem, my dear friend. P greater than or equal to 0. That is, p is some value, 0.1. Any real number greater than or equal to 0, our regular master theorem only. But p less than 0, this is the special case. See, actually, these and this are the special cases which we need to see separately. Rest of the thing is actually exactly same as your master theorem only. So what I do is, I'll apply master theorem and I tell you how to identify. See, for second case, you have to see p value. P greater than -1, p is equal to -1, p less than -1. See, p greater than -1 means you are just multiplying with log n, my dear friend, separately. If p is equal to -1, you multiply instead of log n, you multiply with log n. And if it is p less than -1, don't multiply with that log n factor at all. Don't multiply with that log n factor at all. Just do n power log a to the base b, you have to do it. N power log a to the base b, you have to do it. Am I clear? So let us see examples for this. See, this is the case. A is 5, B is 4, and see this factor. This is log n is the extra factor. So here p value is equal to 1, my dear friend. P value is equal to 1. First, let us consider the same n power log a to the base b. With this, other than that log n, whatever the function is there, that you compare. That fn. I am not taking log n, sir. That log n factor will come, we'll see later. Now here it is n power log 5 to the base 4 versus n. Clearly which fellow dominates, sir? Clearly which fellow dominates? This fellow dominates. See, whenever this fellow dominates, that is n power log a to the base b dominates, that is the answer. No need of checking first part or second part, sir. Theta of n power log 5 to the base 4. It is just first case of master theorem or extended master theorem, my dear friends. Directly you can do it. See, this is the case we use for this. Directly. If you want, you can try this also by putting k is equal to, if you want, you can put k is equal to 1 and you can compare a with b power k. B power k means 4 power 1 with a, because 5 is greater than a greater than b power k. The first case of master theorem, extended master theorem. Now the next example, let us see the next example. Here a is 4, b is 2, okay, and this fn is that n square you are going to consider. P value is 1. P value is 1. Now if you consider n power log a to the base b with n square. Now here it is n square and it is also n square. Both are of equal order of growth. See, both are of equal order of growth. It is same as a is equal to b power k, sir. Because k value here is 2, my dear friend. K value is here is 2. That is 4 is 2 square. The second case. Now it depends on the value of p. P value is 1, which is greater than -1. Since p is greater than -1, what is the time complexity, sir? Simply theta. You can just do this n square log n. You have to multiply with one more log n. You have to multiply with one more log n, my dear friends. That is n square log square n, my dear friends. N square log square n is the answer for this. So that is this particular case. Already this n power log a to the base b is this n power k. Log power p n is there. We multiply with one more log n. This is the case we handled here, my dear friends. Okay. Now suppose here if you are having Tn is equal to, I'll just give you the special cases here itself. Tn by 2 plus n square by log n. See, everything will be same, but here the value of p is equal to -1. So it comes under the second case. This would be the second case. Sorry. This would be the second case. In this case, you just need to multiply n power k with log n. In this particular case, that, sorry. Tn value will be, see this n square or n power log a to the base b, that is n square into log n, you have to do it, sir. Tn would be what, sir? In this case, Tn would be theta n square into log n, my dear friends. Suppose if it is less than minus 1 means you will just get n square, nothing more than that. In that particular case, you will get just n square, nothing more than that, my dear friends. That is a simple story, my dear friends. So if you want example for that, that also you can take. Tn is say 4 into Tn by 2 plus n square by something log n. Whatever it is here, what is this? That log power something is, you write log n is obviously less than that log n only. So minus 1, it is less than minus 2. Or you can take some log power log square n. You can take something like log square n. All these are, t value is less than minus 1, my dear friends. In this case, Tn would be simply theta n square. So these are the three variants, my dear friends, for this. See, first variant. Okay, hope you understand. This is the second variant and this is the third variant. And now let us see this third variant, that is case 3 of master theorem. Here a is 3, b is 4 and p value is 1. Now if you consider n power log a to the base b versus n, this is n power log 3 to the base 4 versus n. Now if you consider these two fellows, obviously this is dominating. See, when this fellow is dominating, you have to see the value of p. P is greater than or equal to 0. Then what is this? This is our regular case of our master theorem. That is nothing but theta and Tn is equal to theta n, my dear friends. So that is our regular case, my dear friends. That is theta n. What are log power, the right hand side function, not n. What is this right hand side function? N log n. The same function you are going to get. This function you are going to get. N log n you can write it. Suppose if you get n by log n in the same problem, suppose in the same problem instead of n, if I get something like t n by 4 plus n by log n, if you are having, same problem is given. Story is exactly same, but the p value here is less than 0. In that particular case, what happens here? You have to say big O of n power k. So here Tn will be simply big O of n, you can say. That log n part is completely removed. That log n part is completely removed, my dear friends. So these are the cases of master theorem, my dear friends. Okay. So what I do is I'll give you some more rules. Just go through it. This is our regular formula. Whenever you have such form, the complexity is theta n log n. So I'll just give you example for this. Tn is equal to theta, okay, n by 4 plus t 1 minus 1 by 4, that is 3 n by 4, and it is beta n, some constant time of n. So simply you can say time complexity is theta n log n, my dear friend. For this form, the time complexity is theta n log n, my dear friends. So these are some rules. Am I clear? So tomorrow we start, we learn this divide and conquer recurrence relation, mainly the merge sort and quick sort based problems we try to solve it. Important versions of these problems, tomorrow we do it. Day after tomorrow we'll do it greedy algorithms, and tomorrow mainly the divide and conquer algorithms, some special problems on this quick sort and merge sort, and if time permits, other algorithms time complexity overview also we'll try to do it. So that is about today's class, my dear friends. If you have any doubts, you can ask me. Otherwise, we'll call it a day. Hope you understand. That's all for today, sir. Thank you. Yeah, this is a new series which is started on our app also. You can take this particular series, GATE 2024 Fundamental Series, and Rank Booster Series also we are doing it on BYJU'S Exam Prep app, my dear friends. So you can also download our free ebooks, and the links are in the description, sir. And you also can register for free workshops which are happening on our BYJU'S Exam Prep app. Okay, and you can also apply for this scholarship test, my dear friends, which is happening regularly. Thank you very much for all of you. That's all for